Okay, this is the second video segment for problem number 1 on the midterm of the other group. I already done the first one and it's posted. This problem, as I mentioned in the earlier video, was in my opinion, a giveaway. I mean, if you knew what you were doing, then there was no excuse not to have got 25 points on this video. But that was the wishful thinking. Okay, so let's start with the product file. I'm going to kill this. I'm going to start it from scratch. So file, new product, and then insert existing components in there, and that's I believe these 3 parts. Good. Let me hide these points because they're distractions. Okay. All right. Now we can create the joints directly, or we can apply assembly constraint and use the magic wand. Now notice that this is a revolute joint. These two, this makes a revolute joint, and also between this crank and the back hole, that makes a revolute joint. However, the other one, that line must slide on this crank, and therefore, or on this cam, and this is a slide curve joint and has to be done manually later on. All right, let's first anchor the wall, and then coincidentally the axis of this pin and the axis of that hole, and coincidence in the face of the wall and the back face of the rod. And if we update, that will go to where it belongs. Good. Now let's insert this cam in. Coincidence, this axis and that axis, and coincidence, but this face and the face over there. And if it doesn't actually look right, all we need to do is to flip the arrow. So if you go to the last one and you flip the arrows opposite, then it looks the way it's supposed to be. Now, in order to create a slide curve joint, the curve and this curve, they must be touching each other. Otherwise, you won't be able to create the slide curve joint. So the first thing to do is to turn this thing around so that they're in the vicinity of each other. So let me rotate that crank about this line, more or less touching. We can't make it exactly touch because it's not going to be an easy thing to do. Now, in order to put these two together, there are different approaches. One of them may be a contact. So a contact between this face and that face. The problem is that this is a curved face and contact doesn't work. And we have the same experience in when we did the I don't know, maybe sliding ladder or well, actually, because this is a arbitrary surface, it doesn't work. So the other option is to go to the sketch for this ellipse and make it tangent to that line. So that ellipse is the crank, and there are other ways. I'm not suggesting this is the only one, but you got to use one of those methods. So we go to that sketch. Let's select this ellipse, control that edge. Let's see if we can make it tangent. Okay, if it doesn't work, try to change them in the reverse order. Okay, there we are, you see? Everything is alright. Unfortunately, if you cannot put these two together, there's no way you can do the rest of the problem. But this was nothing new, we had done it in class. So let's actually save this file, save management, save as. I think that's where it's supposed to go. Good. All right. Okay, so let's switch workbenches. We go to digital mockup, DMU kinematics, get the magic wand out. It's a new mechanism, auto create. All right. So there should be two revolute joints here created. Revolute, yeah, two revolute joints right there. Okay. Now the slide curve, we have to do it ourselves, and because they're touching, we can do that. Slide curve, this and that, and we say okay. The degree of freedom is 1, so we're going to make this cam go at continuously. So crank and the wall, we make it angle driven between 0 and 360. Obviously, mechanism can be simulated. First, let's check it manually. Yeah, that works. Okay, reset, exit. Okay, then we want to create the trace of this point. In order to create the trace of this point, the first thing that you need to do is to create a simulation and then compile it. Okay, so simulation, mechanism 1, drag this thing all the way to the end, insert, rewind, anything but 1, and let's play it continuously. We just make a cartoon out of it. Okay, this creates a simulation that's needed in order to compile. Alright, so let me stop this. Rewind it. I always like to rewind. Alright, and then you go and create a compile. Compile. We want to create a replay and choose this thing to anything but 1 and then play it. Wait until the replay is created. And then you're going to create a trace. Okay, where is the trace? Right there. You see this? Magnifier, magnifying glass. Element to trace is, for example, this point. You want to know what is the path of this point, and the number 101 is the number of points that it's going to take. You can have fewer, you can have more. Just don't do 1 or 2 because that's going to be a straight line or maybe even a point. And this is going to be created as a new part, so you have to save it and then insert. This is what I want you to do, by the way. Create it as a new part. Okay, right here, right there. Okay, so you have to save this thing. File, save management. You cannot insert it without actually saving it first. Save as. Default name, same name. And then we can close this. Save now. We can close it. And then go to our mechanism and say insert existing component. Obviously in our product, and it's the trace that we want to insert. And there we are. And if you create the replay, you will notice that that point will actually track that that path. Okay. Save everything. The next thing is to put some physics into the problem. Now, we are told that the angular velocity of this crank is, let's say, 128 round per second RPM or per minute or 180 RPM. So we have to specify the speed of this. We go to f of x and on mechanism, because we're dealing with our mechanism. And this is the angular position of that cam. So add a formula. If it was, for example, 120 RPM, that means 720 degrees. 7 degrees divided by 1 second, and of course, the formula is times time. If it was 180 RPM, then it was just going to be 3 times 360, 1080. All right, so we have created our physics. Now we're going to create a sensor because we would like to plot a few things. We'd like to plot a let me hide this trace. We would like to plot, where is the trace? Let's hide it. Okay, we like to plot a magnitude of the velocity of this point versus function versus time, and magnitude of velocity versus magnitude of acceleration, or something along that line. I can't remember. One of the problems said do the velocity of this point versus time. The other one said acceleration. And when it doesn't give you component, means that it's the magnitude. Okay, so the first thing that we need to do is to create a sensor. The reference product is the wall. The point under selection is that point. Good. Now we do simulation with laws. The problem specifically said 2-second period, 2-second simulation. So you change this thing to 2. And then you activate sensor. Let us first plot the velocity, magnitude of the velocity of this point. So linear speed, it's yes. And then we play it. There we are. We graph it. And there it is. Okay. Now you have to use the print screen, save this thing, and submit it in your folder, or cut and paste it, or print screen paste into a Word document, whatever. Now the next thing we want to do is to plot the velocity of that point versus the acceleration of that point. So let me rewind this and let me clear the history here. And under selection, we want, of course, the linear speed, and we want the linear acceleration. And then we go to options. We want to create a customized graph, add. We want the speed, which is right here. And for the, I guess, ordinate, we want the acceleration. Acceleration right there. And we say OK and close. So there's a curve one that's going to be generated, just customized, not versus time. Okay, so play it. And when it's done, graph it. Okay. Let me try again. I think my customized graph was not quite correct. Something I didn't ask. Okay. So let me delete this. Remove that. Okay. Rewind. Let's see what is it that we have asked here. We have asked for linear speed and it says angular speed. That's not what I wanted. I wanted, uncheck that. I wanted linear acceleration. This is the one that I wanted. That's why I said I don't have this data. So how do you expect me to do that? Okay, so options, customize graph, add. Let's make sure we pick the right one. Speed, and for the other one, acceleration. Let's make sure that we don't select the angular one. Say OK. Good. Close that. Play it. And then graph. There. All right. Once again, print screen, save it as an image file, and then paste it in a Word document, save it, and then submit it. This takes care of the first problem in both sections, which were really giveaways. Unfortunately, you had to know the steps, and the steps are all identical. Things like that were done in the book, every single chapter, every single tutorial. Now, in some problems I said, okay, I will not put the physics in there, but you should be able to do that, or I will not plot this. You should be able to do that. All right, folks, take care. Bye.